Hello everyone, I hope all of you are doing absolutely great. Today we are going to start a new topic which is gravitation. As I made a notun topic which is gravitation. It will be an interesting topic. I hope all of you will pay attention, then you will love it. Okay, so this is the way I'm going to proceed in this lecture. As I lecture to ki dhorone proceed korim etu moi likhi disu. So firstly, I'll spend some time in telling you the story so far. এতিয়ালৈকে আমি জিমান physics পঢ়িলো in your class 11, how that is helping you build your foundation of physics, that I'm going to tell you. So we'll also see how your things are connected. So this is important to create interest in the subject. Okay, so firstly we'll talk about this, the story so far. After that we'll try to see how different topics finally are they're connected, and then it leads to the study of gravitation. Okay, topics bibhinno topics bu ki dhorone connected hoy ase hetu ami sam, tar pasot ami gravitation le ahi jam, which is the main topic of today. And in the beginning I'll be telling you about the history of gravitation, how different people came up with different ideas which finally led to the main important law which is given by Newton, and that is what we call as the universal law of gravitation. We'll try to see the mathematical form of this law. Okay, and then we will try to see what are the different features of the gravitational force or properties bunu ki hetu ami sam tar pasot. After that, we'll be dealing with a principle, a very important principle, which is called superposition of gravitational force. And this is very important when we are dealing with many body systems which are interacting among themselves. This principle is very much important. We'll try to see. And finally, I'll be doing a few very simple numericals. And as the class proceeds, we'll be dealing with more and more complicated problems. So I hope the picture is clear how and what I'm going to teach in this class. Okay, so let us take the first topic, which is the story so far, ab tak ki jo kahani. Okay, now in this we'll try to see how we are trying to build your foundation of physics. We are following the NCERT books and the sequence given in the NCERT, and we'll try to see how the topics are connected. Okay, but before that, since I am very accustomed to teaching you, and now in a recorded classes I miss my students, so I thought it's a good idea to introduce my virtual student. His name is Tim, and he's saying hi to you. You can also say hi. So his name is Tim, and he will be with me throughout the class, and he will be asking me questions so that I don't miss my students. So yes, so this is your new classmate. Anyway, so going forward with the class. Okay, now these are the chapters of NCERT textbook volume 1 of class 11 that we all are studying at present. Okay, now we will try to see how these topics are connected, and through these topics how we are trying to build the foundation of physics for you. Okay, let us take one chapter at a time. The first chapter that you have studied, I assume all of you have studied the first chapter, that is the physical world. This chapter actually gives a general introduction to the subject, some very like general phenomena which can be explained by physics. আমি চাৰিওফালে দেখি থকা বহুত ঘটনা আছে যিবোৰ আমি ফিজিক্স দি এক্সপ্লেইন কৰিব পাৰো। সো তেনে ধৰণৰ কিছুমান ঘটনাৰ এক্সাম্পল এই চ্যাপ্টাৰটো দিয়া হৈছিল so that we can know the scope of physics. Okay, so this chapter gives an overall picture of the physical phenomena. Are you getting these things? So to make you understand how we are trying to build the foundation of physics for young students, let me draw an analogy. এটা উদাহৰণৰ হেল্প লৈ মই বুজাব বিচাৰিছো how your foundation of physics is getting built up. Okay, let me take an example of a budding chef. What do you mean by budding chef? A kid, he wants to be a chef, for example. He wants to be a cook. Okay, and we want to give him the foundation of cooking or the foundation of culinary science, as we say. Now, how are we going to build that foundation? Okay, eta lora eta jodi he cook bonibo bisare ba chef bonibo bisare, ami ki dhorone ta foundational values bodim, ki dhorone eta foundation dim, so that in future he can be a professional cook. Okay, the first step that we may do is we will introduce him to various dishes. Okay, for example, this is a biryani, this is dosa, and something. We'll show him that look, these are the dishes you finally have to make. Okay, so that we are giving the kid an overall picture in the beginning, and this is exactly what this first chapter has done for you. It gives you different examples how physics is used. For example, how physics is used in lasers, how physics is used in wireless communications, how physics is used in flying aeroplanes. So there are many events going on in the earth which can be explained by physics. So for that, in the beginning, you as budding physicist, all of you are budding physicists, and we are trying to build a foundation of physics for you. So for that, just like if you are a budding chef, we'll try to show you the various dishes which you have to make. Similarly, in this chapter, we are going to talk about the various physical phenomena which are very interesting and exciting, and how physics helps in understanding these phenomena, and how physics helps in various inventions and so on. Okay, now after I've shown you these dishes, what will I do? It's not that I'll directly bring you to the kitchen and say, now you cook this. Now since you have to mize to dish bu sala, now you can directly cook them. No, we are not going to do that for you. What will we do? The next step is that we will make you get accustomed with the various equipments needed. Cooking koribole ki samagri lage, those instruments I will make you familiar with. For example, you can see I'll make you familiar with the gas stove. I'll make you familiar with this is a belan. I don't know, I forgot what it's called in English. I'll make you familiar with the mixer grinder and so on. So what I'm doing after showing you the various dishes, what I'm doing is that I am trying to make you learn how to use the various tools of cooking. One by one, I'll teach you the various tools. That is the step number 1. The first step is just for your motivation, and so that you'll have an idea. Then this is the first preliminary step where I'm trying to make you learn how to use the tools. In a very similar way, what this chapter 2 does is it is going to introduce you to the various tools, various units required. How do you measure things? For example, vectors. Vector is a tool. If you want to study physics, if you want to pursue physics, you have to understand what are vectors, how to deal with vectors, how to add vectors, how to subtract vectors, how to multiply vectors, and so on. We have to make you understand the tools of physics and how we can use the tools so that we can use them for various purposes. Okay, so this is the next step which is done in the next chapter. Okay, now just think, by now this kid has seen the different dishes that he finally needs to make. Now he has got accustomed to the different equipments needed for cooking. What is the next step that it will do? The next step is that we will not ask him to make some very complicated dish. We will start by trying asking him to make some very simple dishes, or we'll teach him how to cook some very simple dishes like rice. This is a plain rice. This is just one item. This is just made of rice. This is just a plain roti. Okay, so we are just asking the kid to learn to make some dishes which just consist of one ingredient. Similarly, after teaching you the various tools of physics, the various units of physics, the various physical quantities, what we are trying to do is take you to the topic of one dimension. That is the simplest case possible. So we are trying to teach you 1D because that's an easy way to start the things and also build up the concepts. So in 1D we studied things like free fall, then some kind of vertical projectile, and so on. Then before that we studied the equations of motion in 1D. In 1D they are easy also because we can write them in scalar form. Okay, so this is what we did for you. First we tried to make you understand the 1D properly. After that, what we will do, then we will go to the next level, that is motion in 2D. So once you are comfortable in cooking plain rice and roti, maybe we'll ask you to make something consisting of 2 or 3 items, for example khichdi or some naan or something. Are you getting? Slowly I am trying to increase your level of cooking. Similarly in this, while following the NCERT syllabus, what we are trying to do is, once you are very much comfortable in using the equations of motion in 1D, now I am asking you to enter into the 2D world. Okay, here what we have studied, here we have studied a projectile motion, a projectile thrown with some incline, or we talked about a horizontal projectile, and so on. We also talked about relative velocity. Okay, so this is how we are trying to increase your, like, as if we are building a foundation and we are going step by step. Okay, now that you, till now what we are dealing with is called kinematics, where we are just studying motion. As I have already told you in class, in kinematics we just study motion. So what is the next step? The next step is that we will study what causes this motion. Are you getting this? আমি যেতিয়া কাইনেমেটিক্স পঢ়িলো, আমি জাস্ট বস্তুটো অবজার্ভ কৰো, এটো এনেকে মোশন হৈছে, 1D মোশন হৈছে, there is an acceleration and so on, but we never dealt with the causes. After that, motion to the whole motion to কিয় হল, এতিয়ালৈকে আমি সেই কোৱেশ্চনটো শুনা নাছিলো. So in the next we entered into what we call as dynamics. In dynamics what we do is that we deal with the causes of motion. So till now you have been cooking simple dishes. Now let's say different dish has different taste. Okay, now this kid who wants to be a future chef, he has reached a stage where he's trying to see what is the cause of a particular taste. He's tasting this, and he's trying to see what is the cause of this taste. Okay, this is a particular taste, maybe because of this is some kind of a spice which has given this taste. So he is now trying to deal with the cause of the taste. So similarly, once we are done with this topic called kinematics, now we are entering into dynamics, where we are dealing with the causes of motion. And to help us with this, we have the Newton's laws, the famous Newton's law, the first law, second law, and the third law, which deals with the causes of motion. And we know that the main cause of motion is what we call as a force. Okay, if there is no force acting on the body, no net unbalanced force, then if your body is at rest, it will be at rest. If it's motion, it will be continuing in motion, and so on. So the main cause is what we know as force. Okay, after that, then once we understand the cause is force, then we try to see the applications. For example, if we can apply a force like this force will move this object, and what we call is that some work has been done. Okay, now how fast you are doing work, the rate of doing work, that will come under power. And why are we able to do work, or in other words, why are we able to apply some force? Because we have something called energy. So all such kind of things we study in this chapter called work, energy and power. So to tell you with this budding chef, what we are doing is, like, now he is know that okay, this taste has come from this particular ingredient, this taste has come from this particular masala or something. Now he can do some experiments of combining different things, and so that he can make some kind of new dishes with the kind of taste that he wants to give. So that is kind of an application. And finally, till now what we have been dealing with is called translational motion, mostly dealing with translational motion. What is that? Like, we are considering point objects and they are just moving. We are applying some force and these point objects are moving. Now the thing is that what if it's not a point object, it's a rigid body? Okay, then the story is not just confined to translational motion. There is one more kind of motion possible when it is a non-point object, there is a rigid body, that it can rotate. So such kind of things we have dealt in the 7th chapter. So in the 7th chapter we deal with these kind of things. So in other words, now we are not just confined to translational motion, we are trying different ways of doing work. One is also called rotational motion. Okay, we go beyond the linear motion. So telling with this, now that he can do experiments with different items to give different kind of taste, he can also do experiments of different ways. For example, he can cook the same thing in some kind of a karahi, or let's say he can do a barbecue, or he can cook things in an oven. So these are different ways. So now this budding chef has gone up to that level that he can do things in various ways. He can cook the same item in different ways. So similarly, just like we are applying force, we are trying seeing translational motion, or we are seeing rotational motion, and so on. Okay, finally we come to the 8th chapter, which is gravitation. So till now we have been talking about force. It's the cause of motion. Yes, till now you'll agree that force is the cause of motion. Now the thing is, you must have heard of various kind of forces. Bibhinno dhoroner forces kotha shunisa. For example, you have heard of viscous force, then you must have heard of friction, then you must have heard of like Coulomb force, and so on. So there are n number of forces you must have heard of, but the good thing is that all these forces can be categorized into just 4 categories. Whatever the kind of forces that you have come across in your life, they can be categorized into just 4 categories: gravitational, electromagnetic, strong force, and weak force. I'll give examples of this. When this is the surface of the earth, an object is falling down towards the surface, what is that cause? That causes gravitational force. For examples of electromagnetic forces are like forces between 2 charged particles given by Coulomb's law. Friction is an example of an electromagnetic force. A normal reaction, suppose you are keeping something on a table and its mg is acting downwards, you know that this table also exerts an equal and opposite force, which we call as the normal reaction on this. Okay, then we have the nuclear forces, which are like strong nuclear forces. For example, inside the nucleus you can see protons, you can see neutrons, but you must be wondering how come so many protons, how come so many protons which are all positively charged, how are they confined in such small volume? They should have repelled, but why is the nucleus stable? The nucleus is stable because there are some strong forces which is holding all these nucleons together, and this is much stronger than the electromagnetic force. That is the reason the nucleus is stable. And finally, the last category is weak forces, and this is the force like involved in processes like beta decay, when from a nucleus an electron comes out in form of a beta ray. So this is the force responsible for this. Okay, so these are the fundamental forces of nature, and any force that we see, they can be categorized in one of these forces. So now we are going to take these forces one by one. Firstly, we are going to deal with this gravitational force. After that, maybe in class 12 we'll be extensively dealing with these electromagnetic forces, we'll be dealing with electrostatics, electrodynamics, and so on. And these two will come in nuclear physics. These two will come in nuclear physics. Okay, so moving forward. Okay, well, team has a question. How is friction electromagnetic? How is friction electromagnetic? इसमें charges तो है ही नहीं. That's a very good question. So I will answer this question. So let us understand this friction. Okay, so that we can understand why I'm calling this friction as electromagnetic. That is a very interesting question, and I think it is going to be an interest to many of you, like Tim. Okay, so to make you understand this, let me take an example of this gentleman. You can see that he's sliding on the surface of the earth. Now if this mass of the gentleman is m, then he will be pulled towards the center of the earth by force mg. We know this. Now since he's not getting into the surface of the earth, that means there has to be an equal and opposite force which is balancing this. That is the normal reaction. Now it appears from his movement that he's trying to give a force towards the right hand side, okay, because of which is moving. But we know that friction acts opposite to the motion. So a friction force is going to act opposite towards its motion. Okay, this part of the story we know. Now the thing is that what is the cause of this? You can see that because of this friction, his sandal has gone out. It's the friction which has caused this. Now what causes friction? To understand this, let us go to the microscopic level. For example, if you take a microscope and see things at a very nano level, you will see that if this is the last layer, if this is the last layer of his chappal and this is the top layer of the ground, friction happens only when the surfaces are not very regular, not very smooth. So you can see some kind of bumps and all are there in the surfaces. So this is the actual condition. So because of these bumps, there are certain pressure points which develops. Okay, and because of these pressure points, when one surface is on top of the other, some kinds of bonds are formed. So this I am talking about the bottom layer of one surface and the top layer of the other surface. So these two surfaces are in contact, and because of which some kind of bonds are formed. We also call it cold welding. Now from the knowledge of chemistry, you know what are bonds. Bonds are basically when you have two atoms, the nucleus of one atom attracts the electrons of the other atom, the nucleus of the other atom attracts the electrons of the first atom, and so on. So what is happening is that the interaction of the charges, that's what we call as bond. So although apparently it seems that there are no charges involved in this process, but at a microscopic level, if we see, we can see that it's because of the formation of various bonds, that means the interaction of charges, that is actually giving a difficulty in the motion. If this try to move this way, because of this bonds which are formed, a friction force is developed. So in that way, since friction is caused by the interaction of these charges, when I say charges, the force has to be electromagnetic force. So that is the reason friction is electromagnetic force. Okay, so now we move forward. Okay, now just before ending this section, I have one piece of advice for you, and that is, while trying to study this book, please do not pick up random chapters and study. This will hamper the foundation making process. Instead, what I request you is that go sequentially, because by now I have already proven how the different chapters are connected from chapter 1 to 8. They are connected, and how step by step your foundation of physics is getting built through these chapters. So it's always like a buffet counter. If you go one chapter at a time, then it's very good for you. You'll have a strong foundation. You will have a strong foundation. But instead of that, if you do it like a live counter, what happens in a live counter? We feel like having pani puri, we'll go and have pani puri. We'll feel like having chow mein, we'll go and have chow mein. Then, I mean, it's totally random. So in other words, if today you feel like, okay, today I'll study work, power and energy. Okay, then tomorrow I'll study projectile. If this is the way you study the chapters, then it'll be problem for you. My advice is that please go sequentially. Okay. Okay, so we are done with the first part of this, that is the story so far. So I hope you have understood the basic idea of how we are trying to take you. Now let us go to the main theme of today's lecture, that is gravitation. So firstly, I'll be talking about the history of gravitation. How the idea of gravitation has evolved. Okay. Now, আমি যেতিয়া যিকোনো এটা বস্তু ফিজিক্সত ইনভেন্ট কৰো বা কিবা এটা আইডিয়া আমি দিও, the main basis of that is always questions. Somebody has asked some very good questions and he tried to find the answers to that, and in the process we came up with new things. So what happened is this: various people had different kind of questions in mind, and while trying to find the answers to these questions, one by one we came up with some good theories which will explain the different phenomena. Okay, for example, why does the moon orbit around the earth? If we are observing, আমি দেখো যে যেটো জুন আছে, it is orbiting around the earth, পৃথিৱীৰ চাৰিওফালে ঘূৰি আছে. Now I should ask, right, why is it orbiting? It could have gone out of its orbit and it could have gone far away from the earth. Why is it not going? Similarly, we can ask, why do planets orbit around the sun? The planets could have gone the way they like. Why are they orbiting around the sun? Then similarly, when we throw a ball up, why does it come down? Why? This why is very important as a physics student. Why? Only when we put it in the right places, we'll come up with new ideas, we'll come up with new physics. Or another question can be, why doesn't the moon fall onto the surface of the earth? Okay, so while trying to understand these questions, while trying to find the answers to these questions, what happened was that many things got revealed. The nature has revealed itself to us, and that is what we study as physics today. Okay, so let's go back to the beginning of this millennium. There was a scientist called Ptolemy. So what he did was, like, he gave us a model of the universe which we call as the geocentric model. Ptolemy namor scientist jone amak geocentric model namor eta idea disile. Ei idea to ki koy je universe or center of earth to ase. It's like all the other objects revolve around us, the earth. That is called geocentric. So earth is at the center, and all the other planets like Mercury, Venus, and even the sun, all the other planets orbit around the earth. That was the model given by this scientist Ptolemy. Okay, next. So in this regard, there was also an Indian scientist and mathematician, Aryabhata, as we all know him. So he also studied the motion of celestial body in great details, and he was the one who established that Earth revolves about its own axis. So it's not just about the revolution of planets around the Earth, but Earth also revolves or rotates about its own axis. So Aryabhatta told this, and he gave description of motion of other celestial bodies as seen from the Earth. So if you consider this as the Earth, what is the motion of this Mars from the Earth with respect to the Earth? What is the motion of this Mars? He studied all these kind of things. And the idea of heliocentric model, I'll come to this heliocentric model in just the next slide, was mentioned in his work called Aryabhata. Okay, so let's see what is this heliocentric model. So a very definitive explanation of this heliocentric model was given by Nicholas Copernicus. Okay, so what this model is the opposite of the geocentric model. It is the opposite of the geocentric model. So what this model says is that the sun is at the center and all the planets revolve around the sun in circular orbits. So that is what we call as the heliocentric model. This is a very big revolution, and he had to go through many problems because of giving such ideas, because even the church and those point of time, they are like very much accustomed to the geocentric model. কোনোবাই যদি কৈ দিয়ে যে নাই পৃথিৱীৰ লাইক বেলিটো পৃথিৱীৰ চাৰিফালে নুঘূৰে, পৃথিৱীটোহে বেলিৰ চাৰিফালে ঘূৰে, এইটো এটা নতুন আইডিয়া. People were not ready to take this idea. So this was the case. Okay, now moving forward, there was another man called Tycho Brahe. He was a very rich man, and he got support from the king of his time to carry out his research. And this is very important, as you know. For example, in India, Indian research is not that level. One of the main reason is funding. So he was lucky enough to get good funding from the king at that time, and he spent his entire lifetime recording observations of the planets with the naked eye. Why naked eye? It's because there was no telescope at that time. See the efforts of this person. Just with the naked eye, he went on to look at the sky, and he made various observations, and he mapped the planets and the stars. So he made various maps. Of the planets, of the stars, and so on, by just observing them. Okay, then he was joined by another person. He was called Kepler. Kepler joined him. Whom did Kepler join? Kepler joined Tycho Brahe. But it happened that Tycho Brahe passed away, and then Kepler got all his maps. So Kepler started studying the maps. So Kepler got the maps of Tycho Brahe, and this person Kepler, he started studying the maps very sincerely. Okay, then what happened was that as he was working on the Mars orbit, he found that the radius of the orbit was not constant. This is a very important observation that Kepler found. He found that if this is a orbit, then sometimes the distance between the Mars and the Sun is huge, and sometimes it is very less. So he found that it was not a constant. So if the orbit is circular like this, and if this is the Sun and this is the Mars, then this radius will always be constant. But Kepler, by studying the maps of whom? Maps of Tycho Brahe. By studying the maps of Tycho Brahe, Kepler has found that the radius of the orbit was not constant. From this, he was bound to draw the inference that orbits can't be circular. They has to be something like elliptical. And this led to the first law of Kepler. So likewise, he formulated 3 laws which are very famous. We will study them later in the next class. Okay, so after that there was another great person called Galileo Galilei. Now till now we saw that the maps of Tycho Brahe, they were by naked eye. But what Galileo did, was remarkable. He made his first telescope in 1609. Now he has a telescope, so because of that he has better resolution. Yes, so using the telescope he discovered the moons of Jupiter. Now the question is, what is so interesting about discovering the moons of Jupiter? It's just another object. But no, there is a very interesting thing here. Till now, those people who believed in the geocentric model, they thought that the earth was at the center and every damn thing in the universe would revolve around the earth. That was the idea of geocentric model. But once Galileo discovered the moons of the Jupiter, they could see that if this is the Jupiter, this is a moon of Jupiter, then this moon revolved around the Jupiter. In other words, this moon did not revolve around the earth, it revolved around the Jupiter. So this was a serious blast to this geocentric model. That means there are certain objects in the universe which does not revolve around the earth. For example, the moon of the Jupiter revolves around the Jupiter and not the earth. So this is an evidence against the geocentric model. So finally, till now what we are looking is that various people like Kepler, then Copernicus and many other people, they had some observations. Based on the observation, they tried to give some kind of laws like Kepler's law and so on. But then nobody was precisely able to tell what is the cause of all these observations. It was the great scientist Isaac Newton who dealt with the cause why, if this is a sun, this is the earth, whether it is elliptical, whether it is circular, that is fine. But what is the cause because of which the earth revolves around the sun? That cause was dealt by Newton. So he summed up everything in the universal law of gravitation. So Newton could tell the precise cause of all the observations made by the previous scientists, and that's why we also call this a universal law of gravitation. I'll tell you why this is universal. Okay, so just a bit of history. He discovered these laws around 1665 or 1666. That time was plague, I don't know how it's pronounced, plague in England. Okay, when Newton discovered gravity. So just now, just like in the present day we are having this corona and we are having this lockdown, a similar situation was there in 1665 in England. And see how nicely Newton has used his time during that lockdown. We do all sorts of things in a lockdown, but Newton has built an entire branch of physics during that lockdown which happened in 1665 because of this illness. Okay, and he provided a mathematical framework. It's not that he just gave qualitative laws that this is how it may happen and so on. He gave mathematical framework. So that's what we are going to deal now. So till now you know how are we are trying to build the foundation of physics in you, how the various chapters of NCERT connected. After studying the previous chapters, how you come to this important chapter called gravitation, and by now you know how the idea of gravitation has come up. You know the history of gravitation. Now let us get to the main business by dealing with the universal law of gravitation. Okay, so this is how the universal law of gravitation looks like. This is the statement. I want every one of you to please look at this statement very, very sincerely. Okay, the first word is every particle in the universe. Just look how strong a statement it is for somebody in the 17th century to write a statement like every particle in this universe. So it has not spared any particle in this universe. Every particle in the universe has to follow this law. The next word is attracts. That means unlike Coulomb's force, which may be sometimes attractive, sometimes repulsive, he says this is only of attractive nature. That means every particle attracts. Attracts what? Every other particle. This is again a very strong phrase. every other particle. That means if this is a particle, then this particle attracts every other particle in the universe, no matter what, no matter how big the universe is or how small this particle is. Such a strong statement it is, if you think about it. So if this is a particle, it is attracting every other particle in the entire universe, however far it is or however close it is, however big it is, however small it is. Irrespective of everything, it is attracting. It is not repelling, it is attracting every other particle with a force which is directly proportional to them, to the product of their masses. Their masses means the product of this particle's mass and this particle's mass, between whom the force is relevant. So which is directly proportional to the product of their masses, inversely proportional to the square of the distance between them. That means as the distance between these two particles increases, the force decreases. Okay, and acts along the line joining the two particles. That means the force will be along this line. If this is a particle and this is the particle and this is the line joining the particle, then the force will be along this line. That means this will be attracted towards this will be attracted towards this. These two forces are along the line joining the two particles. So let's look at the mathematical form for this. For example, okay, I'll use the eraser. Okay, I think this much will be good enough. Okay, so let's say there are two masses m1 and m2, and they are separated. The center of mass of this and this are separated by a distance r. So this law is actually valid for point masses, but the thing is that if they are like not point masses, then it's valid for the center of masses. But this will be true only when the distance between the masses are huge compared to the size of these bodies. So that is the condition. So by that, this is what we mean by point masses. So you see, like as I've told in the law, okay, just one second. Okay, so as told in the law, the force is proportional to the product of the two masses m1 and m2. If this mass is m1 and this mass is m2, the force is proportional to m1 and m2. Then the force is inversely proportional to the distance, square of the distance. So if the r is the distance, the force is inversely proportional. So combining these two will lead to this. That is, force is proportional to m1 m2 by r square. Now if we want to change this proportionality to equality, then we have to introduce a constant, and this is called the gravitational constant, which is the whose value is given by 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this is the universal law of gravitation. So that means if there are two masses m1 and m2 separated by distance r, then we know precisely what is the force acting on these masses. The force on this masses will be in the direction towards the other mass, and this mass, the force will be directed towards the first mass. So this will be the direction. So now sometimes you get a question about what is the dimension of this g. Okay, now we know that g is equal to f r squared divided by m1 m2. So we know the dimension of force. Force is mlt inverse 2. Then the dimension of r is length. So dimension of length is l. So l squared divided by m squared. So the dimension of this universal constant g is m inverse l1 to l to the power 3 and t minus 2. Okay, t minus 2, that's fine, t minus 2. So this is the dimension of the universal gravitational constant. Okay, Okay, now let us try to understand how did Newton come up with this law. Newton is a law to delay. Newton keneke gom pale? How did Newton come to know about this law? Let us try to understand this. We know that the moon revolves around the earth in t is equal to 27.3 days. So this is the time. If this is the earth and this is the moon to complete one complete revolution around the earth, it takes 27.3 days. The distance of the moon from the earth is this much, 3.85 into 10 to the power 5 kilometer. So this is the distance, let's see. Okay, this is the distance. Now, if this moon is revolving around the earth, it must have some centripetal acceleration. And this centripetal acceleration is given by omega square r. Okay, now omega we know is 2 pi by t, so omega square will become 2 pi by t whole square into r. And if we actually calculate this, we know the value of pi, we know the value of t. From this we have to convert this into seconds, we know the value of this r, we have to convert this into meter. We find that the acceleration or the centripetal acceleration of the moon is 0.027 meter per second square. This much is clear. After that, the acceleration of an apple falling near the surface of the earth. So we know the story, right? Like an apple must have fallen in front of Newton or in his body, and Newton was thinking why like this has happened, and finally this led to the discovery of gravitation. Anyways, so let us take an example of an apple. Okay, you can take anything for that matter. So if an apple is falling near the surface, we know that its acceleration is 9.8. When I was teaching free fall, we have been dealing with this g. This is 9.8 meter per second, around 10. So now if we take a ratio of the acceleration of the apple and the acceleration of the moon, okay, you'll see that the ratio comes out to be 3600. This is observation, this is, there are some ways of calculating this, so you know this, and once you know this, you can find the acceleration of the moon, and then we also know the acceleration of apple, which is situated near the surface of the earth. So if we take the ratio of this, it comes to be 3600. Next is, we can also find the distance of the apple from the earth. That is nothing but the this should be distance, this should be moon, and this should be apple. Okay, this should be apple. So distance of the moon from the earth divided by the distance of the apple from the earth. Okay, so this is given, this ratio comes out to be 60. This ratio comes out to be 60. This is moon and this is apple. Okay, this ratio comes out to be 60. Now what we have seen is like 60 square is 3600. That means from this observation we can conclude that the acceleration of an apple divided by the acceleration of the moon is equal to the distance of the moon from the center of the earth divided by the distance of the apple squared, because 60 squared is 3600. Okay, so from this what Newton concluded was that Newton could guess that acceleration of a body towards the earth is inversely proportional to the square of the distance of the body from the center of the earth. So what Newton did was that from this data, okay, I'm sorry for this mistake by the way, like this should be moon and this should be apple, so please like take note of this. So from this Newton could guess that acceleration of a body towards the earth is inversely proportional to the square of the distance. That means as you increase the distance, the acceleration will decrease. Okay, so the acceleration is inversely proportional to the 1 by r square. Okay, moving forward, we know from Newton's second law that force is mass into acceleration. We know that F is equal to ma. We have been dealing with this, F equal to ma. So that means A was by now I know 1 by r square. A is proportional to 1 by r square. So F, which is mass into acceleration, F has to be proportional to m by r square. Okay, is it fine? After that, from Newton's third law, we know that the force on a body due to the earth must be equal to the force on the earth due to the body. That means if this is an earth and this is a body, okay, if this is getting attracted because of this will also get attracted because of this. Okay, it's just Newton's third law. So from there we can conclude that the force will be proportional to both these masses, the mass of the earth and the mass of the object. So we got this, and since this is a proportionality, as I've already told, we will introduce a proportionality constant and we get finally the famous Newton's law of gravitation. Okay, so this is how we get the Newton's law of gravitation. So here you note that one of the object was earth, one of the object was earth. So Newton generalized the law by saying that not only the earth but all material bodies in the universe attract each other according to this equation. So Newton took some daring assumptions at that point of time, which is actually true, and that is this law F is equal to G m1 m2 by r square, that is valid for any two particles. That's why the law starts with every particle attracts every other particles. In other words, if this is a universe and there are 100 particles, then if you take any particle, that is attracting the rest 99 particles. That is the situation. Now you may be wondering, like, if so many particles we are attracting, or we are attracted to so many particles, why we are not moving and so on. This is because our motion, if you have this question in mind, আমি তো ভাবিব পাৰো যে আমাক ইমানখিনি পাৰ্টিকলে এট্ৰেক্ট কৰি আছে, আমি মুভ কিয় কৰা নাই? The reason is, if this is a body, it may be attracted by various infinite number of particles, but the motion of this body will be the net resultant of all these forces. You have studied vectors, you know addition of vectors and all these things you know by now. So the net resultant of all these vectors is r, and the body will move according to this. In our case, all the people who are residing on the surface of the earth, there may be many other forces, but since the earth is very close to us, the net resultant is always towards the center of the earth. That is nothing but our weight mg. All other things are kind of negligible in comparison to this force. Okay, so I hope the Newton's law is clear to you. Okay, so now let us look what are the features or what are the properties of this gravitational force. Okay, it is a central force. Gravitational force is a central force. So what do we mean by this? If this is an object, its center of mass is this. If this is an object, its center of mass is this. Then this is the line joining the centers. This is the line joining the centers. The gravitational force will act along these lines. The gravitation force is not going to act along this. It's not going to act along this, but it's going to act along the line joining the centers. So that's what we mean by a central force. The next thing is mutual gravitational forces equal and opposite. That means what? If this is a big body and this is a small body, okay, it's not that the force on this will be big and the force on this will be small. No, mutual gravitational force are equal and opposite. What do we mean by this? The force on this body because of the smaller body and the force on the smaller body because of this bigger body, these two forces will be same, F1 equal to F2. That is what the law of gravitation says. These two forces are equal and opposite. They are always attractive. For example, in case of Coulomb's law, we know that if this is a positive charge and this is a positive charge, then they are going to repel. If this is a positive charge and this is a negative charge, then they are going to attract. But in case of gravitation, if this is a mass m and this is a mass m, m1 m2, then they are always going to attract each other. There is no second possibility. That's what this law says. Okay, the next property is that it is independent of the intervening medium. That means, for example, this is a mass and this is a mass. Okay, they are attracted because of gravity. Okay, now if I take some kind of a beaker and fill this with some liquid, let's say we fill this with some liquid, okay, then the force will still be the same. If initially in free space, if the force was F, then even if you fill the environment with some kind of a liquid, the force will still be the same. That is the beauty of this gravitational force. It is independent of the intervening medium. So you can see that these are the differences. Like of gravitation from Coulomb's law, because in Coulomb's law the force was k q1 q2 by r square. This k is dependent on the medium. That means if you have a positive charge and if you have a negative charge, then if it is free space, the force is something else, and if it is like in a different environment, in some kind of a dielectric or whatever it is, then the force is different. The force, we had a term like epsilon r, which we call the relative permittivity or something. So there we can see that the force is dependent on the medium between the charges, but here the force is independent of the medium between the masses. So this is one property. The next is like it holds for, okay, so let me just erase some of these things. Okay, it holds for point masses. That means what? If this is the point mass, this is the point mass, only then this law of gravitation holds. But even if it is not a point mass, still it will hold, but the condition is that it should be such that the distance r, and if the radius of this is, let's say, r1, radius of this is, let's say, r2, r should be very, very greater than r1 comma r2. That's what we mean by point masses. So for gravitation, we have seen that it is ideally for point masses, but even if they are not point mass, for example, earth is not a point mass, okay, but then the earth and sun, if you see the earth and sun, if let's say this is the sun and this is the earth, okay, this is the earth, like they are not point masses, but we can explain their like motion by gravity. Why? Because the radius of the sun or the radius of the earth is very less compared to the distance between the earth and the sun. So that's what in like practically we mean by the concept of point masses. And finally, it's a conservative force. What we mean by conservative force is that work done by the force is independent of the path. So by conservative force, we mean that work done is not dependent on the path. That means, in other words, if we go about a circular loop, if we start at this point and take some path and come back to the same point, then the work done, we generally write it as like this: work done along a closed path is 0. So for example, friction is not a conservative force. If you like go about a path like this and come back to the same point, the work done by friction is not 0, but the work done by gravitational force is 0. So it's a conservative force. And finally, it is independent of the presence of other bodies. We'll come to this as we are going to see the next principle, okay, in the next section. So what this means is that it is independent of the presence of other bodies. Means what? If you have a mass m, it is getting attracted to a different mass m. by force F. If there is a third body, let's say P, then this force by which this mass is getting attracted because of this mass M is not going to be affected by this. It will have its attraction towards this, that is fine, but this force between small m and capital M is not dependent by the presence of a third body M. So this is one property of gravitational force. So these are some properties of gravitational force, or features of gravitational force, that we have discussed. Now let us see one important principle which we call as the superposition of gravitational forces. The principle of superposition of gravitational force. Okay. What this principle states is that the resultant gravitational force acting on a particle due to a number of masses is the vector sum of the gravitational forces exerted by the individual masses of the given particle. So let's see what it is. The resultant gravitational force, that means let's say this is our test mass M, okay, acting on a particle due to a number of masses. Let's say this is surrounded by many number of masses, M1, M2, M3, M4, Mn. So there are n different masses surrounding this small mass M. Okay, now we know that it is attractive in nature. Gravitational force is attractive in nature. By now we know that it is like along the line joining the centers. So this mass will be attracted to M1, it will be attracted to M2, M3, M4, and so on. The resultant gravitational force, so this will have a net force acting on this. That net resultant force is given by the vector sum. While dealing with vectors, by now you know how to add vectors. If you have this vector, this vector, this vector, this vector, then all of this combined may give you some kind of a vector like this, which is the resultant. So what we are trying to say is that if you have n such particles, the net force, the net gravitational force acting on an experimental mass is the vector sum. Note this sign vector, it's not a scalar sum, it's the vector sum of all the individual gravitational forces. That is what this superposition of gravitational forces is talking about. So we'll see in problems how this helps. Okay, so let us go to numericals. Okay, so I hope like you are ready with your pen and paper so that you can do along with me this numericals, and I hope Tim is also ready. Okay, well, Tim says that he is not afraid of theory but he is afraid of numericals, but I would like to assure Tim that as you go along these classes you will be very much comfortable in numericals, because I'm going to make you do considerable number of numericals in these online classes, and towards the end of this course I hope you are like comfortable with numericals. Okay, let's try the first numerical, which is 2 point masses of 1 kg and 2 kg are placed at a separation of 50 centimeter. So let's imagine the situation. There is a mass of 1 kg, there is another mass of 2 kg. They are at a separation of 50 centimeter. 50 centimeter means what? It is half a meter. Assuming that the only forces acting on the particles are their mutual gravitation, find the initial accelerations of the two particles. Find the initial accelerations. Now we know that the force is equal to g m1 m2 by r square. You can do along with me. Okay, so g is 6.67 into 10 to the power minus 11. Now the masses are m1, that is 1 into 2 divided by half squared. Okay, this is half squared. So this will become 2, this 2 will go up, it will become 2 into 2 is 4, 4 into 2 is 8, so 8 into 6.67, so 8 into 6.67 into 10 to the power minus 11 Newton, and this will give, let me have a look, will be 5.3 into 10 to the power minus 11 Newton. This will be the answer for this. This is directly and this is a direct application of the Newton's law of gravitation. Okay. Now the next part is find the initial accelerations of the particles. From Newton's second law, we know that acceleration is equal to F by m. So for the first particle, it will be F by m1, that is 5.3 divided by 1 into 10 to the power minus 11. Acceleration will be meter per second squared. So this is just 5.3 into 10 to the power minus 11. A2 will be F by m2. So this is like 5.3 divided by 2 into 10 to the power minus 11. So that is equal to 2.65 into 10 to the power minus 11 meter per second squared. So this is a typical numerical to start with for gravitational problems. So what I have done is just substitute the values in the formula. We know all these values and we get the force. And once we know the force, we just divide it by the individual masses to get the acceleration. That's what we have done. Okay, now let's go to the second problem. Three equal masses of m kg, so this is m, this is m, this is m, are fixed at the vertices of an equilateral triangle. Equilateral triangle means this is equal to this is equal to this. What is the force and what is the force acting on a mass? This is of mass 2 kg. This should be 2 kg. Okay, this should be 2 kg. Okay, sorry, of mass 2m. No, so it was right. Okay, of mass 2m. I was thinking this to be meter, so this is 2m. Placed at the centroid. So you know what is centroid? Means where all the medians like cross each other. That is called a centroid of the triangle. What is the force if the mass of the vertex A is doubled? What if this mass is doubled? What will be the force? Okay, so what is asked in this question is there are three masses on an equilateral triangle. Equilateral triangle means all three sides are equal, and there is a mass which is at the center of the equilateral triangle. That means at the centroid. Okay, and it is given that these are 1. That means the distance from the vertex to this centroid is 1. Okay, so we have to find the net force acting on this mass of mass 2m. Okay, now from the principle of superposition of gravitational forces, we know that the net force at this point will be the vector sum of this force, the vector plus this force plus this force. When we do a vector summation of all these three forces, we will get the net force. What is the net force acting on the mass of 2m? Let's do this. Firstly, what we will do is force on G due to A. Force on this G due to A. It will be G, m1 is m, m2 is twice m, divided by r square, that is 1 square. So it is 2gm square, and the direction is j cap. The direction is j cap. Okay, now let's consider this point B, the force on G due to B. This is G. Now you can see that the magnitude is same. It's always this m, 2m by 1 square. Now what will be the direction here? Now we know from the properties of triangle, if this is the centroid, then this will be 30 degree and this will be 60 degree. This we know from the knowledge of geometry. Okay, now what will be the direction of this? That will be cos 30 degree minus I cap, cos 30 degree minus I cap. And what will this be? What will this be? This will be sine 30 degree minus j cap. Okay, minus j cap. Similarly, the force because of this, the force on G because of this B, this is G m 2m 1 squared. So this will be similar, it's quite similar, this one, it will be cos 30 degree I cap plus sine 30 degree j cap. Okay, so now we know from principle of superposition, we know from principle of superposition that the net force on G, the net force of G on G will be FGA plus FGB plus FGC. Okay, so this is the net force on G. Now if we add up all these things, what we will see is this. Sorry, this will be minus G. Okay, so what we will see is this and this will cancel each other, and all these three are along the J axis, so we'll take 2gm square common, so this will be j cap minus sine 30 is half, that means half of j cap minus half of j cap, because this is also sine 30, this is half, so this is also half, so this is 1 minus half j cap minus half j cap, so 1 minus half, this is nothing but 0. So we see that the net force acting on this centroid is 0, and this we got by the principle of superposition by doing a vector sum of all the forces acting on this. Okay, now let us come to the second part, that what is the force if the mass at the vertex A is doubled. Okay, so let's say now this is twice m. Okay, now from the principle of superposition we can easily conclude that in the previous case, when this was m, this was m, this was m, the force was what? 0. Previously it was 0. Now the extra force will be because of this addition of a mass m to this, so that will be the resultant force, because without this mass m into this, all these three forces were actually balanced. The force at this point, because of this m, it was already balanced, we have already seen. So the extra force is because of this additional mass m. So we can cleverly do one thing, that now the new force, it will be along this direction, and because of this extra mass m, so what we'll do, G, this is twice m, the extra mass is m, the distance is 1 square, and the direction is j cap. So it is nothing but twice g m square j cap. So this is the scenario. What is the force if the mass at the vertex A is doubled? Okay, so if it was just m, then the net force was 0. If it is double, then the net force is twice. Okay, for example, if I say what if this is tripled, if the question is twisted, that what if this is tripled, okay, what will happen is this, then the extra mass will be twice m, so this will become 4gm squared. Okay, 4gm squared j cap. Okay, this is how you need to play with things. Okay, so one last question for today. Two particles of equal mass go around a circle of radius r under the action of the mutual gravitational attraction. So it is said that there are two particles of equal mass, they go around a circle of radius r, they are like going around a circle of radius r because of the mutual gravitation attraction. Find the speed v of the particle. Okay, this is a very interesting question. For that you have to know one thing, and that is, when two such particles under the influence of their own gravitational forces, if they are revolving in circles, then the center of this circle has to be the center of mass. They actually revolve around the center of mass. So this is center of mass. Okay, so if this is center of mass, then you can see that since this is M and this is M, the center of mass will definitely the midpoint of the line joining them, because these two are of equal masses. The center of mass is the midpoint. Now it is said that they are revolving around each other, okay, around this midpoint. So this is, if this is R, this also will be R. Okay, is the center of mass. Find the speed v of the particle. Now we know that if they are moving in a circle, there has to be some centripetal force, and the value of that centripetal force will be mv square by R. Okay, now who is providing the centripetal force? This centripetal force is provided by the gravitational attraction, of these two particles. So that means this force has to be equal to the gravitational attraction of these two particles. Okay, because the masses are m and the distance between this is twice r. So this is the catch of this problem. Okay, now we can cancel one mass. Okay, so this implies v square is equal to gm divided by 4r. Okay, this is gm divided by 4r because one r got cancelled because of this r. So this implies v is equal to half of gm by r, root over. So this is the velocity with which both these particles will orbit around the common center of mass. So this is the question. Okay, so I hope like you understood what I was trying to tell in this class. So if there are any doubts, any questions, you can always ask me in this link. This is a Google form. You can post your doubts or you can ask me questions. So thank you for attending this class. Hope you have enjoyed this.